So, if you guys remember, domain and range, remember, is your set of all your x values, and your range is going to be your set of all your y values or your outputs. So when we're looking at a function, we want to determine what is going to be our domain. All right. So that means every single input value. If you remember, there's a couple things. Every single input value has to map to another value, and it has to uniquely map to the value. Now, there's a couple things a part of a function that are not allowed, where we're not going to have an answer for our x. So we need to look at that and think of what are kind of two constraints that we have in mathematics that are not allowed. Well, there's two of them that are going to come right up to my head. First thing is we know that you cannot have, if you had a number 5, we know that you cannot divide by 0, correct? We know that's something that's we cannot do. And also, when you guys were dealing with imaginary numbers, you also know that you can't take the square root of a negative number, correct? So when we're talking about finding what is the domain of a graph, what we want to do is we want to say, well, in a function, we know that it's going to cover all the x values, but we want to figure out what x values are not covered. And the only time we're going to be able to find what x values are not covered is we need to look for when do these two kind of constraints happen. And if you look in this function, we actually have the possibility of both of them. There's x values that this is going to affect. So if we look on the bottom, what we say is, this looks like this graph, it can cover all x values, but what x values is it not going to cover? Well, if this bottom becomes 0, that's not going to be a part of the graph, right? Because we know we can't divide by 0. So when is the bottom 0? Well, obviously it's pretty apparent for you guys to look on your graph, but to set this up in an equation, what you do is you just write 0 equals x plus 6. So whenever our bottom is going to equal 0, so you just take the bottom and you set it equal to 0. Because whenever your bottom equals 0, we know that that x value cannot exist. So I subtract the 6 on both sides, so I get negative 6. So x equals negative 6. So therefore, here's an x value that is not a part of our domain. And the reason why it's not a part of our domain is because when x equals negative 6, we're divided by 0. That's a no-no. That can't happen. The next thing, you can't have a square root greater or less than 0, right? Everything has to be greater than 0. So the exact same thing. Whenever you have a root, what you're going to want to do is you're going to say x plus 6 has to be greater than or equal to 0. So you always take whatever's in the root and you set it greater than or equal to 0. Because it's okay if a root is 0. You just can't have the bottom be 0. So then, again, it's fairly simple math, but I just solve for my x. So I have x is greater than or equal to a negative 6. So as far as my domain in this graph, if we were to graph this on a graphing calculator or just random points, this graph is going to cover all the x values, infinite x values, except for a couple points. One, it cannot equal negative 6, and it doesn't cover all of the x values that are greater than negative 6. And if you notice, I already say x can equal negative 6 and negative 6. So when I find my domain, the domain is, well, it can't equal in this thing, so your domain is all values that are greater than negative 6. Because you can't include the equals because this, we already say it can't equals. So when I was looking for my domain, it's all the x values that are greater than negative 6. Make sense? So just when you're trying to find the domain, what we always like to call the implied domain, is just set the bottom equal to 0 and set whatever root you have set to greater than or equal to 0. And just solve for those values, and whatever those values are, those are not going to be a part of your domain. So just exclude them, because those are things you can't do. All right, makes sense.